All right, good morning and welcome to Master Talker online class. In today's video, we'll be talking about reflection of, this is physics. We want to talk about reflection of a curved mirror, right? Now, we have two types of curved mirror. The first one is the parabolic curved mirror, and then the second one is the spherical curved mirror. Just the difference between them is that a parabolic curved mirror has a wider aperture or opening. All right. So they'll ask you the difference between the parabolic curved mirror and the spherical curved mirror. We have parabolic, and then we have the spherical. So the difference between them is simply that the parabolic curved mirror has a wider aperture than the spherical curved mirror, right? Then you need to know the uses of a parabolic curved mirror. A parabolic curved mirror is used as a searchlight. Okay, they are used as a searchlight. Then the second the second use is that they are used as a motorcycle or normal a car headlamp. Okay, it is used as a headlamp and it is equally used as a searchlight. Why? Because that the parallel beam of light is same or equal or has a constant intensity, right? They'll ask you what is the reason why is a parabolic curved mirror used as a headlamp. You tell them that the parallel beam of light has the same or constant intensity. All right, please write that down. It's a very important thing to note. The reason parabolic curved mirror is used as a searchlight or a headlamp, okay, is because that the parallel beam of light has a constant intensity. All right, then let's go to a spherical curved mirror. Spherical curved mirror. Now, a spherical curved mirror is just a mirror that is formed by cutting a sphere into two, right? If you cut a sphere into two, you have this and this, okay? Then we have two types of spherical curved mirror. The first one is the concave, and then the second one is the convex, right? Now, the difference between the concave and the convex is just where it is coated, right? A concave mirror is coated at the back. The concave is coated at the back so that the reflective surface will now be inward. It is coated outwardly so that the surface, the reflective surface will now be inward. While the convex is coated inward so that the reflective surface will now be outward. Now, if you see that this reflective surface is inward, it shows that they are converging. It is coming together at a particular point. So they are all converging. If we do this, if you have a parallel, this like this, okay, they are all converging to a particular point. You have this one coming this way, hit this and move to the focus, coming this way, hit this, meet to the focus, and so on and so forth. All right. So that is that for that. Now you should know that they are what? They are converging. They are converging, right? And since they are converging, they converge at a particular point called the focus. They converge at a particular point called the focus. All right. Let me do something like this. I have this coated at the back, or maybe the other way. Anyhow you want to draw it, is the same thing. Or maybe I have this coated at the back. Sorry, coated at the back. It's coated at the back. Then I have this is the pole. Okay, this is the pole, and this is the parallel axis. This is my parallel axis. I have my focus here, and I have my curvature here, right? Then if an image is placed anywhere, how do I? Okay, just know that they all converge at a particular point. Let me check what I'm showing you. Let me see how I can draw it to make sense. If it's coming this way, they hit here. Coming this way, they hit here. Coming this way, they hit here. You see, everybody converges to a particular point called the focus. Okay, so you should know that what a concave mirror is what is converging in nature. converging means they come to a particular point. Okay, it is converging in nature. And since it is converging in nature, they form a real image. They form a real and inverted image. Okay, they form a real and inverted image. I'm going to tell you the image formed in a convex, but just know that generally they form a real image. Okay, and that image is formed on the focus. That is what made the focal length to be positive. The focal length of a concave mirror is positive. I hope you know that anything greater than 0 means positive. Please note that anything that is greater than 0 means positive. All right, name any number that is greater than 0, it is always positive. So this thing I wrote here means that it is positive. So the focal length is positive for a concave mirror, right? So let's talk about the uses of a concave mirror. One, it is used as a distinct mirror. Sorry, it is used as a dentist mirror. Sorry, it is used as a dentist mirror, and it's equally used as a shaving mirror. You can use it as a shaving mirror. They say that it is because that the object is placed. Okay, that is only when the object is placed in between the principal focus and the pole. Okay, if you place it is in between the principal focus and the pole, this is your pole. That is only when you can use it as a shaving mirror. Placing the object in between these two places, you can now use it as a shaving mirror. All right, then and whenever an object is placed between the I'm going to tell you about the images formed in a concave mirror, but you should know that whenever an object is placed between these 2 points, okay, then the image is going to form behind the mirror. And if it is not behind the mirror, it will not be upright. That is why we say that we use it to shave. We use it as a shaving mirror only when that object is placed in between these two people. If not, it cannot be used as a shaving mirror. Just note that. All right. So now let's talk about images that are formed in a concave mirror. Images that are formed in a concave mirror. The first one, if I have a concave mirror like this, remember it is quoted at the back so that it will converge. The first characteristic is that they converge. Okay, so now I have my pole here. This is my pole. This is my F, the focus, and then this is my curvature. Now, if the object is placed beyond the curvature, maybe the object is somewhere here, it is placed beyond the curvature. What happened? We have that this comes here. Don't know how to draw it. This comes here and bounce here, and then move this way. Okay. Let's see that another one comes like this. Okay, let's have the but I know that the image is going to form here. The image is going to form between, this is where the image is going to form, and it's going to be between the C and your F. Okay, the image is going to be between C and F. So if I have another one coming like this, the heat here. Anyhow you draw it, okay, but just know that first, whenever an object is placed beyond, please note this, is very, very important. If it is placed beyond, that is after this C, if it is placed beyond your curvature, then the image is going to form at the center between your C and F. That's the most important thing you should note. Okay, so the first thing you should tell them is they tell me the characteristics of an object placed beyond curvature in a curved concave mirror. Okay, you will now tell them first thing for every concave mirror is that it is inverted. That is why I show the arrow like this. It is inverted. Okay. Now the next one you talk about is it is real. Yes, they form real. That is number 2. The 2 most important is that they are real and inverted. That is the 2 most important. Then the remaining ones you write depends on where it is placed. Okay, the 2 most important is what? Real and inverted. Please, anytime you are writing the characteristics of an image formed when an object is placed in a curved mirror, in a concave mirror, the 2 most important is that they are inverted and they are real. These are the 2 most important you must write. Then the next thing you should tell them is that since it is now placed beyond this man, number 3 is that it's going to be small. The image formed, these are the characteristics of the image formed when you have placed the object. If you place the object, these are now the characteristics of the image formed. First of all, the image is going to be inverted and it's going to be a real image. Then it's going to be small because it is placed beyond this man, or you call it diminished. You don't want to use small, use what? diminished. All right, finally, find number 4 is that the image is going to form between your curvature and your focus. Okay, that is for number 1. Please note this. It's not difficult to understand or remember. Remember that if it is formed here, okay, that's the first place. It is formed beyond your C. The image is going to form between these two people, okay, and it's going to be small. Then the normal or the trivial characteristics of every concave mirror is that it is inverted and it is real. Then number 2, let's go closer, a little bit closer. Number 2, if I have something like this, I don't really know how to draw, but I'll just teach you to remember them. Okay, you can now find the drawing yourself. Now I have that this is my P, your pole, this is your F, and this is your C. Now I want to go a little bit closer. If you go closer now and place it on this man, it is now on our, this is where the object is. Our object is now on the C itself. If it is now on the C itself, the image is going to form on the same C again. Okay, it's going to be formed on the same C, and this time around it does not reduce the size become the same. So if they want to tell you, write the characteristics of an object formed characteristics of an image formed in a concave mirror when it is placed on the curvature, you tell them the 2 most important characteristics of every concave mirror, which is number 1 is what? It is inverted. All right, and number 2, it is what? It is real. Then since it is placed here, the image is going to be the same image with the object. It will be same image or same size. It will be same size. So the image is going to be of the same size with the object. Then finally, it is equally formed at the curvature, formed at C. Remember that this one was formed between C and F, but this one was formed at C. Now let's go a little bit closer again. Number 3, let's go a little bit closer. To go a little bit closer, I have that this is my P, and this is my F, and this is my C. Now we have formed here. Let's now form it here. Let's now place it here. Sorry. If we now place it here, what happened? Please, now this number 3, it is directly opposite of number 1. Just get your answer from number 1. Number 1, the object was here, and then the image is here. So therefore, if the object is here, the image is going to be somewhere outside this man. Okay, but it's going to be inverted. That is where the image will form. Don't know how to draw the lines. You can try to draw the lines yourself. Okay, just note these things I'm telling you. So if you want to write the characteristics of an object placed in a concave mirror between your curvature and your F, you write the trivial one, the most important one. It must be inverted. It must be real. Now where will it form? Number 3 is going to be formed beyond your C. Formed beyond C. It will be formed beyond your curvature. And remember that this one was small, so it's going to be large. It's going to be big or magnified. You can use the word big, it will be big, or use the word large, or use the word magnified. Okay? You see, these are very, very simple. Now, the next one we'll talk about is when it is now formed. Let's go a little bit closer. Please, let me clean this. Let's go a little bit closer. If we go a little bit closer, number 4, we go a little bit closer. We go a little bit closer. This is my P. This is my P. This is my F, and this is my C. Now, if we go a little bit closer and this image is now here, if the object is here, sorry, what happened? The image is going to be at infinity. Please tell them that the image will be at where? At infinity. The image will be formed at infinity. All right? Please note that whenever an object is placed at the focus, the image is at infinity. All right? So that is that. Then if any image is formed at all, that image is going to be real, inverted, and enlarged. The 2 most important is what? Your real and inverted. Okay? If any image formed at all for a concave, it must be real and inverted. All right? So, but note very importantly that whenever the object is placed at the focus, then the image is going to be what? Is going to be at infinity. It's going to be at infinity. All right? Okay. So number 5, the last one, number 5. Let's go a little bit closer. Number 5, if we go a little bit closer, this is your F and your P. This is my C. Now, let's now place this object between these 2 people. What did I tell you here? If this object is placed between these two people, one, that is when you can now use it as what? As a shaving mirror. Whenever it is in between your F and your P, you can use it as the shaving mirror. Why? Because the image will no longer form inside here. The image will be somewhere here. The image will be here. Okay? The image will form beyond the mirror and it's going to be upright. Please, whenever it is no longer inside there, it is outside there, then it is now taking the characteristics of a convex mirror. Because a convex mirror, the reflection is outside. So, and what is the characteristic of a convex mirror? We are coming there. A convex mirror, it is upright. It is not inverted like this one. It is not real, but it's going to be what? Visual. Okay? So please note that it's going to be what? Upright, visual, magnified. It is magnified. You can use the word, it's equally magnified. Magnified. It is magnified and it is formed beyond the mirror. Okay? It is formed or behind the mirror. Let's use the word behind. It is formed behind the mirror. So please note these 5 most important this thing, characteristics of an image formed in a concave mirror. So now let's talk about convex. We have already talked about convex. And then in a convex mirror, okay, let's talk about convex mirror. But we have already talked so much about that. But in a convex mirror, in a convex mirror, now if you have a convex mirror, the first characteristic of a convex mirror is that it is coated inwardly. Since it is coated inwardly, then the reflection will now be what? Outside. If the reflection is outside, what happens? It is diverging. It scatters. It is diverging. Look at it. Everybody goes. They cannot come at the same place. But look at a concave. A concave, the reflection is inside. So they are coming together. They are converging. But for convex, they are diverging. You see, they are scattering. They are diverging. Okay? So that is for convex. Then let's talk about the image formed for a convex. The image formed for a convex, I told you, no matter where you place it, it's not my business. You should know that number one, it is what? It is not real. Rather, it is what? Virtual. If it is virtual, it is not inverted. It is what? Upright. You should know that for a convex mirror. Yeah, they say that for a convex mirror, okay, at whatever position the object is placed, the image formed is always upright, diminished. Okay, the difference now is that in convex, the image is not enlarged, it is diminished. Okay, it is diminished. It is what? Don't forget that the image is placed here. The object is now placed somewhere here. If the object is placed here, this is the object, then the image is going to be sorry. Yes, the object. Then the image is going to be inside there. This is where the image is. You see, the image is going to be small, okay, and it's going to be upright. It doesn't invert. It's going to be upright, okay. Then it's going to be, it is diminished or small. You can use the word diminished or small, and it is formed behind the mirror. It is formed behind the mirror. You see, it is always formed behind the mirror. Okay, so, and it is a virtual in nature. So that is that for a convex mirror, right? So they say that an object is placed at a distance u in front of a curved mirror of focal length f. If the image form is upright and magnified, then the mirror is concave with u 2f, convex with u 2f, u equal to 2f, then convex with u equal to f, concave with u equal to half of f and this. Okay, so the answer is B. A convex mirror never produced a magnified image, and so it cannot be a convex mirror. A concave mirror can produce an upright and magnified mirror only when the object is placed between F and P. Okay? So now let's now talk about the calculation. That is where my strength is. Let's talk about the calculation. let's do some mathematical magic. Yes, let me call it magic. So, but before that, you need to know some definition. You need to know some definition like what is a pole, what is an aperture, focal length, principal, blah blah blah, blah blah blah. The use of a convex, convex mirror. You need to know the uses of a convex mirror. It is used as a driving mirror. Yes, that's what we use as our driving mirror. Okay. Then it is equally used as a wide range. Okay, sorry. Okay, it's equally used as a security mirror. It is used as a what? A security mirror and what? And a driving mirror. So that is that. Why? Because it has a wide range of vision. Yes, it has a wide range of vision. And no matter the position of an object, where the object is placed, it's always upright and erect. That is why we use it as what? As a driving mirror. So your driving mirror is a convex mirror. All right. So let's move into the real game. And the real game is what? The mirror formula. The mirror formula. Now, now for the mirror formula, let me have a mirror, a curved mirror like this. Drawing is my problem. Okay, let me use what they said here. They said consider a ray traveling from a point O, from an object O along the axis which strikes the mirror perpendicular pe- perpendicularly and is reflected back along the axis in figure. Let me draw the figure. I have that this is my O. Oh, problem. The only issue I have is drawing. Shit. Okay. Let me try to draw it. So that I'll have my. I want to get a straight line here. Okay. Let me have a straight line here, and I have um, drawing is not easy. So this is my O, and this is my C, and this is my I. Where's this is my M, according to what they are drawing, and this is my alpha. This is my M. So this is my Y. Okay, and this is my beta, and this is my theta, and they say that this is another theta. Uh, okay. So that from here to here is theta, and from here to here again is another theta. Problem. Hmm. Okay, sorry. They said that here is theta, and then from here to here is theta again. Okay. Now, from what I have here, now let's do some stuffs. Now I have that. Do you know that your y is equal to theta plus beta, and the reason is what? Two opposite interior angle of a triangle is equal to the exterior. All right. Okay. Then you should equally know that your alpha outside here is equal to what? Uh, sorry. You should know that your y, huh? Theta plus beta is equal to y. Okay, and then here theta is equal to alpha. I'm trying to get something straight here. Okay, you know that your alpha is equal to your y plus theta. This plus this is equal to this. So here, this small place. Okay, and you should now know that your y now is equal to what? Theta plus beta, or beta plus theta. Let me write like that: beta plus theta. Okay, there's a little error in the drawing. Okay, so you have that this plus this is equal to this, and this plus this is equal to this. So that is that. So draw your own very well. Now, since we have this, I want to bring out a triangle that I'm seeing. If I bring out this triangle, I want to bring out this triangle. Okay, this is my M. I hope you know that the distance from here, to here, the image distance is called your, look at how I used to remember, I, O, image and object. And in my alphabet, I comes first before O, so V will come here, then U will come here. My U will come here. Okay? And that's how I remember it. So the image distance is V. The image distance is V, and then the object distance, the object distance, the object distance is U. The distance from the curvature to this place is our R. This is our R. You should know that. So here is my U. Okay? From here to here is my R. Okay? And then from here to here is my V. So now let's do something. This is my beta, this is my Y, and this is my alpha. Okay? So according to according to trigonometry, you should know that, want to know what is our alpha, beta, blah blah blah, the rest of them. Let's know what it is. Okay? What is our beta? Let's know what these three things is. My beta is equal to opposite. Okay, they say that the distance from here to here, let's call it H, the height. This is the height. The height are always the same. This is the height. Okay, this is according to Sokatua. This is opposite over adjacent. Opposite H over adjacent. Adjacent is from here to here for this big triangle. This big triangle. Okay. Let me call this place I'm talking about this big triangle. This big triangle now. This is opposite over adjacent, and the adjacent there is your V. You get that? So let's check what is our Y. Our Y is equal to opposite again, H. Then the adjacent there is R. From here to here, adjacent here is R. Okay. Then from our R, our alpha here is alpha, not R. So for our alpha, opposite again, H over adjacent. Or adjacent here is U. Okay. Now let us do elimination method here. Let us eliminate theta. We don't need this theta. Let us eliminate theta and see what happens. I have that my alpha is equal to Y plus theta. And I have that my Y is equal to what? Beta plus theta. So let us subtract this minus this. I'm going to have that alpha minus Y is equal to Y minus beta. This and this is gone. All right. Now let me collect like terms. I'm going to have alpha plus beta is equal to what? Y plus Y. So alpha plus beta is equal to 2y. Now let us now substitute everything we have gotten. Our alpha is H over U. So I have H over U plus H over V is equal to 2 into my Y is what? H over R. Okay, so this is going to be what? H over U In fact, okay, let me bring out, they have h in common. If I bring out the h they have in common, this is going to be 1 over u plus what? 1 over v. This time this will give this time this will give this, is equal to what? Let me swap these people. H into 2 over r. So h can cancel h to have that 1 over u plus 1 over v is equal to what? 2 over r. But don't forget that what? That your f is equal to what? R over 2. Don't forget this important formula. That is, your R is equal to 2F. You remember when I said that? Okay, please, very, very important. So therefore, if this is over 1, turn this upside down, turn this upside down. So therefore, 1 over F means 2 over R. So I have 2 over R here. This implies that my 1 over U plus my 1 over V is equal to what? 1 over F. These are the two most important formula you need to note. This formula and this formula. These are the two most important formulas you need to note. Okay? So we can now solve some calculations to illustrate what we have done so far. So the first question we will solve. Okay? So the first question here said number 3. Okay, number 1. Don't know where number 1 and 2 is. Don't know. Okay, let me call it example 1. Said an object is placed in front of a concave. Okay, I'll be right back. Okay, maybe in the next video we'll solve some calculations. Bye bye.